let's have a look today at negative indices. We're going to give you the 7th index law, and it goes like this, guys. A to the minus n equals 1 over a to the plus n. Now, I'll show you how this works. If you had, for example, a cubed over a to the 5, and you were to do this the long way, you would have a times a times a over a times a times a times a times a, in other words 5 of them on the denominator. And you would know that you can cancel top for bottom of the same beastie. So there's one lot of cancelling, two lot of cancellings, and three lot of cancellings. And what we're left with is a 1 on the numerator and two a's, that is a squared, on the denominator, aren't we? But guys, if we do this same calculation using the index laws, in fact index law number 2 from the previous video, we would know that a cubed over a to the 5 is a to the 3 minus 5. And when you work that out, by simplifying, you'll get a to the minus 2. But of course the badumch here, guys, is the badumch, roll the drums, is this is exactly the same as this. So this answer must be exactly the same as that answer. So I've proved it to you, guys. I've proved it to you that a to the minus 2 is 1 over a to the 2, okay? This is this formula in action where these n's are 2. A to the minus 2 is 1 over a to the 2. This begs the question, what about 1 over a to the minus 2? Well, that looks really confusing. But if we were just to take that a step further and unpack it a bit, we're going to get this. 1 over, and this little beastie all by himself is in fact 1 over a to the 2, as we found out above, didn't we? And you know what happens when you divide by a fraction, don't you? You invert the fraction and multiply by it, so you get that. You see? Now, what does that mean? It means that a to the minus 2 is 1 over a to the 2, as we worked out in the first step, but it also means that 1 over a to the minus 2 is a to the plus 2. So what it means is if you've got a negative index, guys, you can just take that to the other place. E.g., if your negative index is in the numerator, you can take it to the denominator as a positive. If your negative index is in the denominator, you can take it to the numerator as a positive. Just like that and just like that. Okay? So, if you have a negative index, you can move from the numerator to the denominator as appropriate, or from the denominator to the numerator as I've showed you above, and turn it into a positive index. Alright guys, so we have this summary. We know that a to the minus n is 1 over a to the plus n, and we know that 1 over a to the minus n is a to the plus n over 1, if you like. So, let's do some examples now. Express each of the following with positive indices. Alright, x to the minus 3, we know that that is 1 over x to the plus 3, and that's with a positive index. So we put a box around that and we're very happy. So what about b now? b is 2m to the minus 4 n squared. Okay? So we have to make that m with a positive index, don't we? So that's 2 times 1 over m to the 4 times n squared, yes? So just writing it like that now, dispensing with the multiplication signs, we get 2n squared over m to the 4, and that's our answer. Alright, c now. c is 4 over a to the minus 3. Well, we know what to do, don't we? We just take this a to the minus 3 up to here, and it becomes a to the plus 3. So it's 4 times a to the plus 3 over 1. Dispensing with the multiplication sign, we just get 4a cubed, guys. Let's do some more now. We're on a roll. Okay, these look a bit harder, but fear not, we'll be fine. There's number a. We've got a squared b to the minus 3 times a to the minus 5b, and we have to express our answers with positive indices. Alright, so there's a. Now, This little beastie needs to go down to the denominator as b to the plus 3, and this one here to the denominator as a to the plus 5. So we get that, don't we? Now, I can see some cancelling happening here, can't you? So looking at our b's first, we've got b to the 1 here and b cubed there. So what we can do is we can cancel this b with one of these three b's. Remember, it's b times b times b. That will leave b squared, won't it, on the denominator and a 1 on the numerator. Now looking at the a's, we've got these two a's here will cancel out with two of those 5 a's and leave 3. So that will cancel out, leaving a cubed on the denominator. So it looks like our answer is 1 over a cubed b squared. All right? Excellent. Okay, this one looks pretty interesting. We could do our x's first this time. So we've got x to the 1 on the denominator, x to the 4 on the numerator. So that denominator will cancel out with the numerator, or one of the x's in the numerator, leaving x cubed. And similarly for the y's, you tell me what you would get. Yes, on the denominator you'd be left with y cubed. Yes? Okay, so it looks like our answer is 2x cubed over 3y cubed. Great. We're going very well. Now, this one. We've got this. Now, this is a pretty interesting one. Let's think about what to do. I think a nice, simple simplification step would be to get rid of this negative index here by bringing this n to the minus 2 up to the numerator as n squared. Before we do anything with the bracket surrounding all of this, let's just do that, just to clear our head a bit. Well, that looks pretty good, doesn't it? It looks a lot simpler. So now, we've got this negative 2 here. Remember, we have to express our answer with positive indices. So why don't we just take the whole contents of this bracket here and take it down to the denominator, raised to the power plus 2, I think. That's pretty good. We can get rid of this bracket now by multiplying the bracket out. So that would be 2 squared times m cubed squared times n squared squared, okay? And use the appropriate index law to work all that out, and you would get 1 over 4, which is 2 squared, m to the 3 times 2, which is 6, times n to the 2 times 2, which is 4. And we've done it again, guys. Alright, one last example for us, and then we can finish up. We've got to evaluate 6 times 3 to the minus 3 without using a calculator. Well, no problem for us, guys. So 6 times 3 to the minus 3. Alright, why don't we just get this little beastie down to the denominator as 3 to the plus 3, and then see what we're dealing with here. Alright, so 6 over 3 times 3 times 3. And of course, 3 times 3 times 3, in my book, is, what is it? Yes, 27. Now I think we can cancel through by something, and what would that something be? Yes, right again, it's a 3. So 3 into 6 goes 2, 3 into 27 goes 9, so it looks to me like the answer is 2 over 9, which is mighty fine, isn't it? Alright, so we'll just do our summary now, and then we can finish this up. So remembering, a term with a negative index can be expressed with a positive index using the 7th index law. So we know that. What do we know, guys? We know that a to the minus n is 1 over a to the n. We know that 1 over a to the minus n is a to the plus n over 1. Okay? And in shorthand version, just to help your head, if it's a negative index, take it to the other place. Okay? If numerator, take it to the denominator. If it's on the denominator, take it to the numerator as the positive index. Alright? Secondly, all index laws apply to terms with negative indices. Yes, they do. Thirdly, always express answers with positive indices unless otherwise instructed. And lastly, numbers and pronumerals without an index are understood to have an index of 1. Okay, off you go. Do lots of practice and have some fun, and we'll see you next time.